Now, in the reality, NASA wants to go to Mars. So although all this sounds very appealing because it will be more easier to do it, but at the same time, yeah, they said, but we already sort of been in the moon, so let's try instead with one shot to do the same thing to Mars. So since it's more complicated to get to Mars, we have also more time to prepare for these important things. So we want to arrive there in 2037. We already had multiple, as I was saying before, rovers studying Mars. We have Spirit, Opportunity. Here is a selfie done by Curiosity. So Curiosity took a selfie of himself in Mars. And not just because it's, as we do it, to show it, to post it on Facebook that we are in things. Yeah? Yeah. But this he did it especially to make the scientists see that it was safe, that every part was good, you know. So through this picture, they can see that everything is where it should be, and that is working. Now, the Mars Village, there are a proposition to do it in the Valles Marineris, that is a sort of canyon, and this because there is less thermal excursion and there is also different type of gravity. What they also are going here in this project, what they are thinking is to use the thermal shielding of the modules that are coming in the Mars surface as a roof. So instead of using the inflatable membrane, the 3D printer to make the honeycomb structure and cover it up with the material, they said, okay, we have the shielding, the thermal shielding, which is very strong. We can just reverse it upside down so that it can be our roof. Very good. So if you send a lot of them, again with the inflatable membrane down, and then in addition, you can build up a sort of 3D honeycomb structure on the top of it and cover it up with material of the Mars surface. You can get something that it might look like this. So this is a possibility, and is worked by Foster and Partners, this possibility. And this is how it will look inside. And essentially, there is also something going on here in Hawaii, and that is called the Hawaii Space Exploration Analog and Simulation, that is an habitat on an isolated Mars-like site that is in the Mauna Loa on the Big Island. And they are taking, it's an experiment, so they are taking very useful information to be sent to NASA, to be provided to NASA, how it is to live in such an environment. And if you look at it, it might be similar to the Mars surface. So also here in Hawaii, we have something to test this type of housing. Another one, which is the most appealing for the time being, is the project from Search and Clouds, which instead of Villa Marineris that it was here, the one that I showed to you before, wants to build a village up here where we have ice. So use ice instead of the material of Mars. So here you see how the house will look like from the outside. It's all made of ice, essentially. Why ice? Because ice absorbs infrared and ultraviolets, protecting from the radiation, and is also transparent to the light. Because if you remember in the Moon Village and the Mars Village, essentially you are going to be all the time inside this module without being able to see the sunlight so much, right? Just from the window. So they said, what if instead we build up a house that is made of ice, so that we can have much more exposure to the sun. Yes?
Is this known as the Mars ice dome concept? Because like I read up on a concept where they would use ice to create like kind of a house thing, and then apparently ice protects against the solar radiation, and it also like the temperature, I think I read up on it, kind of helps.
Indeed, for the temperatures, what they do. The temperatures in the reality is a bit more tricky because it's a ice house, so it's cold. But, So first of all, you see here internally how it will look like. So let me get to your point. You see here internally how it will look like with all these type of going up and down in order to be able to make reflections of certain radiation that you don't want. And then in order to insulate it, what they are going to use is aerogel. So aerogel is a very light material that is used, it started to be used for in physics, so in experimental physics. But then in the reality has been used also in building, like the Allianz Arena, that is Munich, or the water cube that you see here. And so they are going to put it there. It's transparent, very light, but at the same time is a very good thermal insulator to keep the temperature more stable. So if you look at this house in Mars, it looks very similar to an igloo that already exists on Earth, right? And what is good about it is that it's sustainable and that uses local material. That is exactly what we want to do also if we go to another planet. Now, if it's the moon or if it's Mars, but anyway, the new colony, we want to take care of the environment. We do not want to change the environment that is there. At the same time, we also want, again, copying from nature, we want to have different things cooperating. So for instance, we have this Physiala physialis that is made up of different minute individuals that are good for the mutual benefit in symbiosis. And the same, it might be here, because indeed we have a lot of carbon oxide and we miss oxygen. But so the best thing is to bring plants, right? For them, what is the major things in the Mars atmosphere is good, and they just provide you oxygen. So if we have, for instance, hydroponic plants using just a mineral nutrient solution in water, they can produce you oxygen that then the astronauts can breathe. So here you see from the outside, so you see the eyes, you see the structure that I showed to you before, made with the aerogel that is going to insulate. So this part is pretty cold, but from here on, we go inside a part that is instead a much better temperature. You put all the plants here that are going to produce you oxygen so that you can live in a better way. And these hydroponic culture are already used. Here you see a building in the downtown of Korea, because of course with your cars, you are producing more monoxide of carbon. But with plants, if you also put plants in the downtown, then you can produce oxygen, and so you try to balance. And another example that is really good in nature, and that is similar to what it would happen to Mars, is, for instance, the termites. The termites, what they do, they're using a complex ventilation system to keep in their nest the temperature and humidity that is perfect for them to garden the mushrooms. Down here, that is what they eat. So when you see all these openings here and there, and you think that they are just casual, they are there, but they might be in a different location and it doesn't really matter, this is because you don't know how good they are. Because in the reality, they are able to do it in such a way that you have the right humidity and the right temperatures for these mushrooms to grow. And here, so we have, again, a multiple subsystem cooperating to survive in a sustainable way. So my conclusions: the human desire for exploration leads to discovery. Discovery requires technical solutions that do not yet exist, embracing multidisciplinary aspects. You have seen today that there is a lot of engineering, but there is a lot of architecture too. There is agriculture, there is medicine, there is of course physics, math, all the things and astronomy, that's for sure. but also all this biology, all these other things that you might not think immediately when you think about space, and they have all to cooperate. Plus, we have to study nature because nature had so much time to adapt to circumstances and complicated situations that they found by itself the best solution. So we have to learn and copy from that. And then science is nourished by creativity that is particularly necessary to overcome challenges. And often the solutions that we find for space, they have application different for the original purpose, resulting in human advancement. So as I showed you before, the ski boot, now you will still have very heavy ski boots if it was not for, you know, something like this. Or if you look at the airbag, so also the concept of the airbag was because we needed to make land these very precious satellites in our, these very precious robots in the Mars surface without crashing them. So we have lots of applications in real life of what we do. And today we have studied that cosmic radiation is still a barrier to go to Mars, and people all over the world are working together and facing this challenge to make human manned mission to Mars possible. Because, you know, I look at here and one of you could be the next explorer to Mars. Who knows? You have the right age to be in this. I'm a bit too old, but you, instead, you could be one of them. And then if you look at this picture here, this is a picture. What is this blue dot? It's Earth, exactly. So this is Earth. It was taken on February 1990 by Voyager 1. So Voyager was sent out to explore the solar system, and it made this beautiful picture of the planet. And so consider again that dot, that's here, that's home, that's us. On it, everything you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. It's not from me, it's from Sagan. Okay, so thank you very much.